Close your eyes and imagine standing beside the Nile thousands of years ago. The river rises and falls with a rhythm older than memory. When the waters retreat, they leave fertile soil and erased boundaries. Farmers stare at the land, uncertain where one field ends and another begins. In that uncertainty, numbers are born not as abstractions, but as survival. Egyptian arithmetic begins with counting grain, measuring land, calculating taxes. Mathematics at this stage is practical, grounded, inseparable from daily life. Numbers are tools to restore order after chaos. They are answers to hunger, to construction, to administration. Egyptian arithmetic reflects humanity's first structured attempt to quantify reality. To count is to impose clarity on the world. When you assign numbers to cattle or bricks, you reduce ambiguity. The psychological significance is profound. Numbers offer control. In a world ruled by floods and droughts, arithmetic becomes a way to negotiate with unpredictability. It transforms uncertainty into calculation. The pyramids rise not only from stone, but from numeric precision. Mathematics here is power disguised as practicality. But numbers alone cannot explain the shape of the world. As civilizations expand, curiosity shifts from counting objects to understanding space itself. In ancient Greece, mathematics turns inward, seeking not only answers, but proof. Geometry emerges as a disciplined exploration of form. Lines, angles, circles, no longer just visual experiences, but logical entities. Greek geometry represents a radical psychological leap. The Greeks were not satisfied with knowing that something works. They wanted to know why it must work. Euclid's axioms did not measure land for taxation. They built a system of reasoning from self-evident truths. Mathematics became philosophy written in symbols. This stage reflects humanity's hunger for certainty. If arithmetic organizes the material world, geometry organizes thought. The idea that complex truths can emerge from simple assumptions introduces a new intellectual confidence. Proof becomes sacred. Logic becomes a pathway to universal knowledge. Mathematics shifts from tool to language of truth itself. Yet geometry remains tied to visible space. Lines can be drawn, angles can be seen. The next transformation requires abstraction beyond sight. In the Islamic Golden Age, scholars translate, preserve, and expand Greek knowledge. But they do more than inherit. They innovate. Algebra is born. Algebra liberates mathematics from concrete shapes. Instead of triangles and circles, symbols represent unknowns. Equations describe relationships. The unknown becomes solvable not by measuring, but by manipulating ideas. This is a profound psychological expansion. To accept that a letter can stand for a number is to accept abstraction at a new level. Islamic algebra reflects a civilization comfortable with intellectual synthesis. Mathematics becomes more flexible, more powerful. It can now solve inheritance disputes, calculate trade, predict astronomical events. But more importantly, it introduces the concept of systematic generalization. With algebra, humans demonstrate that reality can be encoded symbolically. You no longer need physical objects to calculate. You operate in a realm of pure relationship. This stage reflects an increasing trust in the invisible structures underlying the world. Mathematics becomes less about what you see and more about what you deduce. Then, time accelerates. Calculus emerges in Europe, describing motion and change. Probability quantifies uncertainty. Non-Euclidean geometry challenges the very nature of space. Modern mathematics explodes into countless branches. Set theory, topology, logic, statistics. Numbers extend into negatives, fractions, irrational values, imaginary units. Infinity becomes something to analyze rather than fear. Modern mathematics represents the ultimate abstraction. It no longer merely models the physical world, it constructs entire conceptual universes. Some of its structures describe reality with astonishing precision, governing physics, engineering, economics. Others exist purely within logical frameworks, yet later find unexpected application. The boundary between discovery and invention blurs. Psychologically, modern mathematics reveals humanity's boldest intellectual trait. We are willing to explore ideas untethered from immediate experience. Imaginary numbers once seemed absurd, yet they now power electrical engineering and quantum mechanics. Non-Euclidean geometry once appeared theoretical, yet it underpins the theory of relativity. Mathematics repeatedly proves that abstraction today can become necessity tomorrow. Across this journey, from Egyptian fields to Greek proofs, from algebraic equations to abstract modern theories, mathematics mirrors humanity's evolving relationship with certainty. In the beginning, we counted to survive. Then we reasoned to understand. Then we symbolized to generalize. Now we abstract to transcend limitation. Each stage reflects a deeper psychological pattern. Arithmetic reflects our need to manage the tangible. Geometry reflects our craving for logical order. Algebra reflects our comfort with symbolic thinking. Modern mathematics reflects our willingness to confront infinity, paradox, and uncertainty. Yet, something remarkable remains constant. Mathematics is a silent language connecting civilizations across time. Egyptian scribes, Greek philosophers, Islamic scholars, modern scientists, all participate in the same unfolding conversation. It is one of the few human creations that accumulates without erasing its past. A theorem proven centuries ago remains true today. Mathematics also humbles us. The more we discover, the more we realize how much lies beyond comprehension. Gödel's incompleteness theorems reveal limits within logical systems. Chaos theory shows how simple equations can produce unpredictable behavior. Even in the most precise discipline, uncertainty persists. Perhaps this is the deepest insight of our mathematical journey. We began by using numbers to control the world. We now use mathematics to explore realities beyond direct perception. Quantum fields, curved spacetime, infinite sets. Yet with every breakthrough, new questions arise. Certainty expands, but so does mystery. In learning to count, prove, solve, and abstract, humanity has been mapping not only the universe, but its own cognitive potential. Mathematics is evidence that the human mind can grasp patterns embedded in reality. It is also evidence that reality exceeds any single framework we construct. So as modern mathematics ventures into dimensions we cannot visualize, and infinities we cannot fully imagine, perhaps the most important question is not how far our equations can go, but how they reshape the way we see ourselves. If the universe can be described in symbols, what does that say about the relationship between mind and cosmos? And in chasing perfect logic, are we uncovering the structure of reality or the limits of our own understanding?